Hey, hope you're all having a good day. My name is Hector. I'm going to go through question 43. So, the century-old Ascensores in Valparaiso, Chile, I think I said all those words wrong, but stick with me, are picturesque cable cars built on stilts to keep the passenger compartments level as they go up and down the steep hillside. In the figure, it shows one car ascends as the other descends. The cars use a two-cable arrangement to compensate for friction. One cable passing around a large pulley connects the car. The second is pulled by a small motor. Suppose the mass of each car is 1,500 kilograms. The coefficient of rolling friction is 0.02, and the cars move at a constant speed. What is the tension in the connecting cable and the cable to the motor? So I went ahead and just drew out for cart 1. So I have kind of circled cart 1 here in yellow. In drawing that force diagram out, I personally like to tilt. It makes it easier. Most of my forces are on that tilted plane, so I tilted it by 35 degrees, which is why gravity is not pulling straight down anymore. This is our tension to the motor, and this is our tension between carts. I don't know why I said T sub P, but it's T sub P, so that's what it is. And we just kind of can look at this and simplify the forces. So as we see, as we sum up, they should be equal to 0 because there's no acceleration, and we need to find Tm and Tp. Okay, so going on to cart 2, this is the cart on the bottom that should be descending. We have the tension pointing to the right, the friction pointing to the right, and the cart wants to move to the left, so those two will oppose. So if we sum up in the x direction, we can say that we get this right here. We get the force of gravity sine minus the friction force minus the tension force should be equal to 0. We can then solve for this tension force, and this is kind of the process of doing it, not really numerically yet, but everything is plugged in as a number right now. And this should give us our tension between the two carts. And then we can take that tension we found in this step and apply it to the next one. So we can now plug in T, because it's no longer unknown, as these two numbers right here. Simplifying that down, we'll get this. So the 2 equals static friction. Most of these things will cancel out. This is a positive that will cancel. This will cancel, and these, of course, will add as a negative. And then you can get this expression right here for tension. And so plugging those out, these two out right here, so this one and this one, we get that the tension between the two carts is 8,000 newtons approximately, and the tension in the motor, that string in the motor, is about 481. So just a quick logic check. Does this make logical sense? I personally think it makes logical sense. If you think about this top cart, it's being pulled by 2 strings, really, right? And then this one is just being held up by this 1 string. So really, the tension in the string of the pulley should be much greater than the motor. The motor has to basically compensate for the rest of that pull that this bottom cart isn't already exerting on this top cart. So our numbers make sense. Our process makes sense, just using Newton's second law and a little bit of Newton's third law to understand the pairs of forces, that the tension will be the same for both carts. And yeah, and that'll really get the job done. I hope you have a really good day.